Hello everybody, and good evening from Sarawak, from Borneo. It's right now almost 7:50 p.m. Sorry, almost 7:20 p.m. Okay, mark 7:20 p.m. here in Sarawak in Borneo. It's 30 August 2026 on Sunday. So we are 8 hours ahead of the Universal Time Coordinate and 7 hours ahead of the British summertime. So that's basically it. And yeah, we are not going to be too long. Okay, so we are go for the live, shall we? So let's go. So hello everybody, and good evening once again. I'm Dennis Suguwa, your host today, for us to witness and watch the launch of the SpaceX's Falcon Heavy from the from the Kennedy Space Center, from the LC-39B, if I remember correctly. And yeah, we are going to watch the launch of the Nancy Grace Roman Space Telescope, which will be launched for today, and it will be heading to the Sun-Earth Lagrange Point too. So we are going to see that. And yeah, anyways, I'm actually very sorry as well that we don't have too much time to adjust everything else. So yeah, that's why. And anyhow, okay, strong back retract.
Call that Falcon
Okay,
Heavy is getting pressurized, and so that you're pretty much
okay.
getting up to
So
flight
hold on
pressures.
for a
Make
little
sure
bit
that
of
the vehicle's
seconds.
nice
We
and sturdy.
I'm going to
As
tag
Zach mentioned before,
here.
that TE, or the transporter erector, rolls the Falcon Heavy out from the pad and then takes it vertical. But a little
Okay,
bit later here, in just maybe 15 seconds or so, you'll see the clamp arms up
okay.
near the top.
So
They'll
I'm
actually
back
pull
again,
away from the top transporter
and
center,
yeah, that's basically
and then we just had a
okay.
call
Strong
for strong back
back
retract starting,
retract
which
has
is
already
great.
started.
That's pretty much just it'll recline a few degrees just to get out of the way for when Falcon Heavy lights,
Okay,
and hopefully
should be
goes off
good.
to space here in 4.5 minutes.
And as the launch pad
Okay,
machinery gets
should
ready
be
and
good.
into its launch positions,
Okay,
we are
so here we
expecting the
go.
NASA
And
side,
anyhow,
the NASA launch manager, to
you can
conduct
see the strong back has retract has already
the
done. And in case you want to know why there's like the logo of the Roman Space Telescope looks like there's like a bunch of
So as
images
the
there,
NASA launch
that's
manager
basically
launch this
TLDR in
morning,
the
we are at
nutshell.
T minus
That's
3
basically
minutes
where the
45
all of the
seconds for
sensors are very
on-time liftoff
important. That's
just after
basically being split out
7:26 a.m.
after
of NASA's Roman
after
Space
the
Telescope.
initial
Yeah, that NLM
imaging
pull is a really important one.
by the
That's the
Roman
NASA
Space
launch
Telescope
manager, like you
using
said,
its
giving SpaceX
own
launch
mirror there.
director the go that the
Basically,
NASA team is
it
ready.
uses
Behind
there.
the scenes, the NLM would have
Okay,
gone and
split
pulled
up
his
the image
engineering
in
team, the
between the
spacecraft
sensors,
team, safety and mission
and that's
assurance,
basically how
and
we
everybody on the
able
NASA
to
side to
take
make sure that
take
everybody
the
is
image
green and
and
everything's
capture
looking
it
healthy, which is
pretty
great.
fast.
And then
If
that's
I
where
remember
we
correctly,
just go for the launch. So we are cleared for
it's
launch
not
for NASA.
resolution. It's more like how many time,
And we have, as the
how
rocket
many resolution
continues
area
to put its
that it's able to
final
capture.
propellant on board,
From what I know, it's basically 100 times more the
we also know that the spacecraft
than the
sitting
Hubble
on
Space
top of the
Telescope, even
nose there
though
that's
the
heading
mirror
into
size is
space
actually the same.
does
If I
run
remember, the
internal
mirror size is
power.
between
So it is
4
burning
to
off of
5
the
meters, something
batteries.
like
Of
that.
course,
Yeah.
it's covered
So
up
that's
by the
basically it.
fairing, but it can run on
And
those
yeah,
batteries
basically
for
also
maybe
TLDR in the nutshell itself, from what I know, is that
before it has to
this
hit its
also
sunset.
packed with the
Yep,
its
that's for
own
sure. And we just heard on the
stereo
loops,
spectrograph.
launch load is
So in
complete
other
for
words,
stage one,
if
which
it
is a
wants to
great,
image
great sign.
something's
So we're going to
a
get
little
back
bit
to
far away.
Hawthorne
For example,
and
if you want
then
to
Zach for
capture
the last two and a
something
half
like
minutes
the
before launch.
exoplanet, okay, because usually the sun, as especially the star flare, basically it can blinds the vision of the telescope itself. So basically, there's where the spectrograph actually works. It's block that sunlight and then able to see whether or not there's actually exoplanets and here and whatnot. And also it will also will be used for the imaging of the dark matter, dark energy, from what I know as well, and a slew ton of other features as well, uh, including the imaging of the galaxy, the universe, whatever you can name in the nutshell. And this one will be able to accomplish the imaging way faster than this Hubble Space Telescope. So that's basically it. And that's the TLDR in the nutshell, what you need to know. Okay? Okay,
And there's that call
that's actually very good.
closeouts. Now looking ahead at the T-minus will enter startup, and
Okay,
the onboard flight computers will take over the launch countdown, and both stages will begin
okay,
pressurizing for launch.
should be good.
So we should be hearing that startup
Okay,
call in
get ready.
just a few
And
moments.
anyhow, I'm using the International Rocket Launches stream. Yeah, even though it still uses from the NASA, because this one is actually quite close to the
And there it is. Falcon Heavy
real
is
time, so
now in
that's why.
startup, and those flight
And you
computers are
can see
counting
there,
down. So we're now just waiting
this is
on the final
the
go, no-go
Falcon
from the
Heavy
launch director for today's
on the
mission.
go. Let's hope for the best. Okay,
And
launch director
great
has
news there.
already
For
given
today's mission. So let's sit back and watch as
has already been
Falcon
given
Heavy
permission
takes
for the go.
Nancy
So
Grace Roman
go,
Space
Paul.
Telescope to space.
Go Falcon Heavy. Go Nancy Grace Roman Space Telescope. So let's go. Okay, T-minus 20 seconds. Okay, a little bit freeze, but anyhow, okay, T-minus 20, 19, 18, T-minus 17, 16, T-minus 12, 10. Okay,
9, 8,
here we go.
7, 6, 5, 4, 3, 2, 1.
All main engine ignition of the Merlin. Liftoff! We have liftoff from the Kennedy Space Center. Liftoff carrying the Nancy Grace Roman Space Telescope on boarding the SpaceX's Falcon Heavy. We have liftoff. And you can hear the sound.
Looks like a beautiful launch so far, Steve.
Wow. You can hear the sound.
Down and then now tracking up, looking at those 27 Merlin engines, lifting the Falcon Heavy and Roman Space Telescope off into space.
Falcon Heavy soaring.
Power and telemetry nominal.
Okay, here we go. Power and telemetry is nominal.
Florida sky. We are 53 seconds.
Okay, but anyhow, it's still good. It's okay.
Into max Q.
Get ready for the... Okay, Falcon 9 is supersonic.
Speed and altitude very quickly.
Here we go.
Engines will throttle down
And get ready for the max Q.
to reduce the mechanical pressure.
You shall see from the... Okay, from the atmospheric water vapor there, behind the rocket flame exhaust there, you can see that's how do you know it's actually already passes by to the max Q. Maximum aerodynamic pressure fully loaded on the rocket itself, on the launch vehicle, as it goes to the event itself. And since it's already passed, it's already throttled up back from 60% to 100%.
We will then have MECO
of the
main
throttle profile.
and then stage separation of that, as well as second engine start one following that. Now, those two boosters will be heading back to Florida today. They'll be doing boost back burns to put them on trajectories back towards Kennedy in Florida. Now, we should be hearing that call out for BECO in just about
and get ready for the booster engine cutoff. Mostly on each of the side boosters. We will see that soon will happen. Oh, okay. So you can see each one of the engines has already shut down. Okay, booster engine cut off.
Side booster separation confirmed.
And side booster separation has already confirmed. And here you can see it's going out itself from the booster core. I mean from the main stage core there. Okay, the boost back startup has already begun.
So at this point, both Falcon Heavy
so that's pretty good. That's what we want to see so far.
Each side booster will undergo on the way back to Cape Canaveral Space Force Station. Now, the primary objective of the boost back burn is to quickly reorient the side boosters onto the required return trajectories, and this is required in the event of a return to a launch site as opposed to a drone ship ocean recovery. And today they're headed towards
Yeah, and in case you want to know, this center core will be expanded, so because it needs to maximize the orbital velocity and especially energy needed to send the Nancy Grace Roman Space Telescope into the heading on the way to the Sun-Earth Lagrange Point 2. So that's very important. If I remember from what I actually can see, the orbit parameters will be around 190 kilometers by 1.2 or 1.8, whatever is it, but almost. Oh, and we have MECO main engine cut off, and we have second stage engine start number 1, SAS1. Okay, but that's basically it's around 190 kilometers by 1.2 million kilometers. We are talking about million kilometers on its highest point, and from that highest. Okay, and payload frame separation is already confirmed, which finally exposes the Nancy Grace. Yeah, you can see. Yeah.
You can see one there on your screen.
You can see there the payload fairing half has already been separated and jettisoned, whereas the mission is still going on accordingly.
Payload fairings jettisoned.
All vehicles are following nominal trajectories.
Okay, nominal trajectory. This is what we want to hear so far. So far, so good. And then after that, we will see on the
acquisition of signal. Important step. Really, just getting spacecraft's just sending its pulse over the NASA systems.
Yeah, that's right. The acquisition of signal should hopefully be coming up here in a minute or so. That'll be the first opportunity that the spacecraft
acquisition of
quote unquote talk to the ground station
signal.
The folks back at Goddard,
that
so
one
make
is
sure that
basically to
it's
do a little bit
still happy
handshake
and healthy
from
on the way,
the
during the
SpaceX
stage 2 boost run,
telemetry
everything's
to
looking
the
good as
NASA
far as
telemetry
telemetry is concerned
for
right
the
back. So you can see there
satellite itself
the
as well.
nozzle extension glowing
Especially
orange
very
as
important
it's
for the space
going around the
telescope.
Earth.
Yeah. And we shall hear the entry burn will start respectively for the side boosters. And yeah, just for your information, the Nancy Grace Roman Space Telescope, this one is actually inherited by NASA from the NRO, from the National Reconnaissance Office, with the excess, how do I say, leftover spice satellite that they no longer use, especially because they've already canceled it before, so they just donate it to NASA. And one of the space telescope is okay. The how do I say, the satellite is okay. Okay, entry burn has already started for the side boosters. Okay, okay, so you can see there. Here we go, and we have shut down of one of the side boosters.
We just had the entry
Wow!
burns on those side boosters
That's
as they're
actually very
making their
interesting.
way
You
back
look
to
at
Earth
that.
right now. Now, as mentioned
Look at
earlier,
that.
we will be attempting
There's
to recover
a
both
little
side
bit of the
boosters, which are
exhaust
targeting a landing
trailing
at
as
landing
well.
zone 40
Wow!
and a landing at landing zone 2 at
Unbelievable.
Canaveral Space Force Station.
And you can see this is
And you
the
can
tracking
actually
from
follow
the optical
vehicle telemetry
ground tracking camera there.
of those side boosters via the
Here you can
telemetry on
see.
your screen there.
And yeah, just okay, FTS is safe.
Now we're just waiting
Okay,
for those
transonic
landing
of
burns
one
to
of the
start up in just
side
about
boosters.
10 seconds from now.
Get ready. We'll move this instead because this is more interesting, and then we can discuss again. And we have one of the side boosters has already ignited for the landing burn, and should be another one as well. Here we go.
Stage 2 is in terminal guidance.
Okay, landing burn has already started. Hey again, hello Dev. Hello. And one of it has already landed, and another side booster as well. Should be. Oh.
landing confirmed.
Eh? Serious? Is that all? What happened with another one boosters there? Okay, what happened
And
to
we've
the
got a
another
beautiful
boosters
shot
there?
of one of those side core boosters
But
there on the
anyhow,
screen.
that's not
We did, of
entire
course,
focus. We will
have
shall see
confirmation of
the
successful landings of
second stage
both of those side
engine
core boosters, and
cutoff number
certainly most
one.
people in the
We shall
vicinity
see that soon
heard those
for the
sonic
Seco
booms.
one.
Now, coming up next, we are expecting the shutdown of the second stage MVAC engine, and this is known as second engine cutoff one, or
Yeah,
SECO one.
so you can see the altitude
And we
is
should
already
be hearing that
gaining
call
up,
out here
191
shortly,
kilometers, and
afterwards we'll just be
shut
waiting for
down
confirmation of
the
good
second
orbit.
stage engine cutoff number one, shut down. At the,
Nominal orbit insertion.
yeah, nominal
And there's
orbit
that call
insertion
out
has
for
already
nominal
confirmed,
orbital
and
insertion
the
after we
orbital velocity right now is
turn off the MVAC engine
26,623
on the second
kilometers per
stage there.
hour.
So coming up next, we have
And
a bit of a
the
breather coming up
terminal
before
countdown
the
right now
next
is
milestone
at
for the mission,
T plus
SES2,
9 minutes.
when the MVAC engine on the
Basically
second stage
around
restarts as it continues
basically
to
around
its orbital
540
destination. So
seconds
let's
into the
hop back
flight.
over to Megan and Dominic at the Kennedy Space Center in
And that's
Florida.
very
How did
good.
that
This
launch
is
look,
what we
guys?
want to look so far.
Amazing. Almost didn't make it back
Yeah,
here.
Oh.
and also
Went
I
up
can
that
I can give you a
launch.
little
In
bit
some ways, I could never
what you
believe
want to
this
know.
moment would
What
actually
NASA
happen.
actually
It is
launched
here
is
and
actually a
far more beautiful than I could have
NRO
imagined.
satellite's
Yeah,
former
yeah.
spy satellite.
Oh, I'm
It's
so
basically
glad. Thank
turned
you so
into
much
the
for
Space
what you do
Telescope,
and this. Oh, yeah,
where
no, thank
basically
you
the
for
NRO
sharing
back
it with
around,
us.
if I remember,
Again, the
2010,
you guys and the
actually
team
gave
have
two
developed
of
here
its
is amazing.
unused
We built this in order
unused
to
spy satellite
provide
to the NASA. But
emotionally
well, when NASA
impactful
got,
and
it's basically
scientifically
just,
important
how do I
imagery
say?
for all
It's
of
basically
humanity,
just in
and
the
I feel like
capacity
we
we
have
call
managed
this
to achieve that
bare
today.
minimum.
And now it is up in
So NASA
space.
have to work
On
for
its way
themselves
there,
what
let's
they need
actually take
to
another
do
look
some
at
kinds
that
of
launch just in case
refurbishment
you
and
missed
whatnot,
it.
and
It was
then
just 10 minutes
they
ago from
will
here at Kennedy
were
Space
able
Center.
to do it
One,
over the times.
ignition,
Okay, so
and
this is
liftoff.
replay.
Go Falcon Heavy and go Roman
Okay, so
Space
this is the
Telescope.
replay. Ha! Interesting, isn't it?
Again,
in
NASA is
case
hoping
in
that
case you are
this
actually
mission will help answer some
in
of the
case you are
biggest mysteries in the
you're
universe, and in order to do
missing
that, it
out,
has to
this is
go
what
more
actually
than a
happens
million
around
miles away to a place
around
called Lagrange
10
Point
minutes
2
and
or
22
L2.
seconds
When
ago.
could we start
Okay,
seeing data from Roman?
this is what
Dominic, to
you're
start
looking
answering some of
right
those
now, the
audacious questions
replay
we talked about?
of this
Well,
view.
Roman is on its way, but a million miles is a long distance.
It
It'll
is.
take
Yeah,
about 3 months for Roman to get
and
out there.
I
We'll be
need to
turning it on
look
and
again
commissioning
on
the
the
observatory
chart
as a whole,
just
so that
to
when
get
we get
myself
there, we can
correctly.
begin taking operational
And
observations
yeah,
right away,
for the
and those data will start to
second
become available in
second
public around
stage
early
engine start
2027,
number
and we'll
2,
be
it will
releasing them
happen
every
at
day as
T
we
plus
process the data.
24
That's
minutes
phenomenal.
and
Can
33
you
three
wait just a
seconds,
couple more
and then
months?
followed by the
We can wait a couple more months because
second
we've got a
stage engine
heavy load
cutoff
of
number
work to
2
turn this instrument
around
on and make it as amazing
around 2
as it was
minutes
designed to
after
be.
that.
Absolutely. And
And
so
then
again,
and then the which
a
is
lot to
at T
unpack about
plus
this mission. If you have any questions
26
about anything
minutes and
that we're talking about, send them
32
our way by
seconds. And then
tagging at
after
NASA
that,
anywhere
followed
where
by
you're
the
watching
Roman
this broadcast.
Nancy
Hey,
Grace
Roman is a
Roman
flagship
Space
mission, as we've been
Telescope
saying, for NASA
deployment, which
science.
will
For
happen
those
at
in Martin
T
now,
plus
is Nikki
31
Fox,
minutes and
Associate
31 seconds,
Administrator for
which will
NASA's
be
Science
around
Mission Directorate,
3
and Sean
minutes, sorry,
DeMarco
4
Goldman,
minutes,
NASA's
around 4 minutes
Astrophysics
after the
Division.
flight, and then the Roman Space Telescope will
Hi,
deploy,
Megan.
and
Like
that's
you said, I'm
basically
joined
it.
here by Nikki
The
and Sean,
missions
and I
will
have to say,
be
I was able
going.
to watch your faces right
And
after
yeah,
the mission launch.
we
I
will
don't think I
let
have ever
NASA
seen
actually
people more
speak and
excited,
talk
probably, to see a spacecraft
anyways,
lift off.
because
So
I don't
congratulations,
have too
first of
much
all,
else
to the both of
to
you.
say. And also,
Extraordinary
yeah,
launch, extraordinary being able to
apologies
see
in
it.
advance,
Thank you
not
for very
in
kind of
advance,
saying you saw both of us
apologies
cry
as well,
last
that I
time.
actually go
It's
live
incredible moment. So,
around
Nikki,
5
we talked a lot
minutes
about the orbital
before the
volume
launch, because
information
how do
that
I
this
say,
mission is going
it's
to.
actually really complicated behind the scene what actually what actually happened. I can say, yeah, it's actually
Are
really
there other universes
it's
like
actually
it? Are
really
we correct in what we
complicated.
know about our
Let's
own
just say
universe?
that
Absolutely. I mean,
that
Roman
that
is
basically
going to
one of my
revolutionize
friends
the way
actually
we look at our
he
universe.
have
It is going to
weird
measure
weird
dark matter, which is, I know that sounds
Windows
bizarre, but it's
related
like the
issues that
fabric
I
of the
need to
universe.
solve.
It's
It's
the things that you
basically
can't
around,
see, but we know it's there.
yeah, it's
It's going
basically
to
I
measure
have to solve
dark
it like
energy, which kind of powers the
3 hours
universe.
plus
And they
before the
have sort
stream.
of a cosmic struggle
Imagine that
between dark matter
I'm
that wants to
basically
pull
just
things
going
together and dark
to that
energy that wants
phase,
to push
try
things
to
apart. And
adjust
that
it
will allow us
here
to
and whatnot,
finally
and
kind
then
of
after
explain
almost
our universe
giving up,
and understand our
finally
place in it.
everything else
Not
is
only that, it's going to find a
in
whole
the place and I don't have to reinstall. I don't have to reinstall again the laptop. So
we
Yeah,
don't
that's
even know
really
that,
good.
billions of
Fortunately, I'm still
galaxies,
on time
tens
to
of
go
billions of
to cover about this
stars.
stuff because
It's
that's
just
what I want to do.
spectacular.
And yes,
Oh my goodness,
especially
it's so
Dave,
poetic the
I'm
way
also
you
very
ended out
happy
like
you're
that.
able
And
to come in,
Sean, for you,
even
this
though
is just one
it's been
of
a
many
while,
telescopes that
isn't
we
it?
actually have in the NASA fleet. Tell us,
And
how does this work together with the other
anyhow,
instruments that
also
we
I
have
want to
in
tell
space
you
to be able
that
to get a
when
better
NASA
picture
actually
of the universe
actually
the way we
get
live?
this
So thank you. The
two
best way I could describe it is
two
imagine you're
former
taking
spice
pictures of the
satellite by
forest.
the
You get pictures
NRO,
of not just the forest and
it's
trees, but
basically
the
a
birds
very bare
on the
minimum.
leaves,
And
on the
from
barks
what
of the
I can
trees.
tell from the
We have
report,
special
one
telescopes
of
like
the
Hubble and James Webb that zoom
uh,
in and take
how
pictures
do I
of those
say,
birds.
one
And
of
we have
the
other
space telescope is
telescopes that do the
basic.
panoramic
Sorry,
view. They
one
get
of
the
the
whole forest.
former spice
Roman is a
satellite basically it
superpower,
has some kinds of
superpower because it can
minor
take
defects that
it can get
needs
the whole
more
forest
time
and then zoom in
to
at
adjust.
exacting
But
time
one of it
and
is
count the
actually
birds
really
on the branches of
almost
those
perfect.
trees.
Just
And when you
need
think about it, like
to
what
do
is
some
it
kind
doing
of
that you're in
stand up here
ecology,
and
except these are
whatnot.
birds and trees
And
and
that's
forests?
basically where
We're kind of
NASA
like
actually
supernova
working.
galaxies, so we
They
can
decided
study
to just
not
work
the ecology of the known universe, but
with
the
the
new
much
universe
better
design.
unit.
So
The second
it's
unit
an
that
amazing thing,
I
and
actually
I'm just honestly
told you that one
thankful
is
for just how
not
many
only
people
has some
put their
kinds of
hands on this thing. Not their literal
defects and
fingerprints,
whatnot.
but
It's
their hearts and
basically
souls went into it. We're
specifically
so
about the
thankful for all the people that
manufacturing
made this happen.
flow.
Oh, well, Sean
And
and
NASA
Dave, thank you
decided
both so much for
they
being
want to
here
expedite
again,
everything
and
else, so
congratulations
they used
on
the
a
first
beautiful, beautiful launch.
very
Thank you.
good unit of it.
Such a good day.
And the second
Megan,
unit
we're
we
gonna come
don't know
back to
what
you.
how do I say, and the units that not really the best. I'm not sure what will happen with it. Maybe they will do something else better, who knows. Here in not whatnot. So yeah.
Again, so much excitement around this launch again
Oh,
because it could just
I
discover so much we don't know
I actually
about
don't
our own
I actually
universe.
didn't use the
Again, we've been taking some of your great questions live
Wow.
throughout the
No, no,
show,
no.
so we have
I
time
didn't use
for
the
more now. Why don't we
wall
pull up
charger.
the
Wow.
first one
That's
on our
pretty
screen
surprising.
here?
But anyhow, I'm going to run
What other
this
things will
as
Roman
much
be
as
able to
possible
observe
until
besides
the
dark
separation, and now
energy,
after
dark
that
matter, and exoplanets?
I will
Well,
end the
Megan,
stream.
that goes to right what we were just
Not
saying
because
about
I'm not
Roman.
interested,
It
but
has such amazing
but
potential
well
for
because
discovery. One of Roman's
but
surveys
because I
will be
need
to look
to
out into our
have a
own
dinner as
Milky
well
Way
after
galaxy. Looking at the plane of our
doing
galaxy,
all of this
we
stuff,
can
and then
see
I
with
need to
Roman's
go back
infrared vision all the way to the center
to
of
my
our
friend's room
galaxy
again
and beyond
just
and through and out the
just to
other
adjust
side.
everything else
That's a part of
with
our
the
own
laptop.
home
I need to do
galaxy that
some
we've
final
never
check,
seen in detail
everything
before.
else,
Wow.
make
We
sure
will
everything
find
it
tens
works,
of
and then
billions of
yeah,
stars, young
I have to
stars,
go
old
to sleep.
stars,
But
stars all the
well,
way across. It'll be the
anyhow,
largest
that's basically
astronomical
it. Is
catalog
what it
in the
is.
history of
Life's
astronomy.
giving me
Wow, I'm actually
headache
getting
at this
goosebumps.
point, but
Looking at goosebumps as
I'll
we're
try
talking
to do
about it,
my
because
best.
again,
Okay,
just to discover so
so
much
that's
is
why
so
I'm able to come
intriguing.
in,
All right, let's take another
despite
question
all
now.
of that problem.
Yes, what else do
Yeah,
we have?
and I'll
What
let
will the
NASA
next
just
future
talk
telescope be like? Great
talk
question.
Well,
for
the
this
Roman
then.
coronagraph is designed to test out those new technologies, as we heard about from Dr. Jason Rhodes earlier today. It's a very complex set of new technologies that will block the light of a star so we can see the reflected light of planets orbiting around the star. Roman can see a planet like Jupiter around a star like our sun. The next observatory will have a similar coronagraph that can detect an Earth around a sun-like star.
So smaller and closer. That's really
Yes.
incredible. So for more than 2.5 centuries, America has pushed the boundaries of space exploration, and it continues today with Roman's journey to deep space.
250 years ago, 13 colonies laid the foundation for the greatest and most enduring democracy in the history of the world. One driven by courage, faith, and freedom. From that moment, we became a nation defined not by where we stood, but by how far we
Yeah,
were
so this
willing
is
to go.
basically just a little bit of
We conquered
stuff
vast frontiers,
related to
invented
US, so
tools that shaped the
yeah,
modern world,
you don't necessarily
found
have
light
to
in the
agree,
dark,
but
and we
this
rose from
one
the
only
earth.
put in for the information.
Faster,
And you can see,
higher,
if I remember, that
farther.
one is for the
We
X,
pushed
what,
beyond the sky
if
and
I
into
remember
the
correctly,
unknown.
X-15 space plan?
Today,
Yeah, if I
our
remember correctly.
curiosity stretches farther than ever.
Oh,
American
and also
robots
even the
search
Apollo
ancient
missions.
rivers of
Oh,
the
yeah,
universe.
yeah, the Ingenuity and also
Telescopes
the
unfold to glimpse the first
Ingenuity and
stars.
also the
For
Perseverance
250
spacecraft.
years, America has
Yeah, I
paved the
remember
way for
that.
humanity forward.
Oh, the ISS,
But
the
American
Hubble,
exceptionalism
the
isn't
Hubble
inherited.
repairing service there,
It's earned.
mission back when the
Heartbreak
space
comes
shuttle is
not
still
only
up.
from what we've done,
Yeah, yeah,
but what we're
back when
still determined to discover.
back when space shuttle was
Because
the
in every
still
era,
the thing back
across
then.
every horizon,
Oh.
America is at its
And
best
and
when it's
if
reaching
you
for
want to know,
something greater.
the Hubble Space Telescope, it's not actually intended to be repaired. Yeah, for the most part, it's not intended to be repaired on orbit. But, you know, especially when the
Now, once operational at L2,
reveal
Roman will
back
help us
after the
study
launch
things
in
like dark
1990,
matter and dark
when
energy.
actually
But
they
again, they've
decided
been
to just
saying they're invisible.
calibrate the
So
telescope
how
and
can we
whatnot,
see
they
things
open it
like
up,
that?
they
Well,
they
Roman
found
can use
out
gravity as
there's
a tool.
tons
Dominic can
of
explain.
Well,
images
Megan,
flow
everything in the
and
universe has
whatnot,
mass,
especially
has
with the
gravity associated with that
glare
mass.
stuff
Gravity
out of focus,
bends light,
and
distorts light, and it
that one is
therefore
actually
distorts
become
images.
one of
So when we look out into the
NASA's
universe, past
humiliating
all that dark matter, the gravity of
period
that
as well,
dark matter
due to
distorts
that kind of issue,
images of the
and
galaxies we
they
see
actually
beyond
able
it.
to trace out
And
till
so
they
we
are
can use this
basically
as
they
a
are
tool
able to trace
to
out the
measure the
problem is
distortion
actually
of those
coming
galaxies.
from that
We can
manufacture of
infer the dark
of
matter
the
between us and
optics
them,
itself.
and we can
So
make
yeah,
a three-dimensional map
and
of
then
all of the
NASA
foam
basically have
of
to
dark
go
matter
and
that's
send
out
again
there
the
for the
missions
first time.
here and
I
there,
think I follow
why
you,
not
but you
do
said that
that
there's
kind
a
of
visual
servicing
way to show
Let's
upgrade
demonstrate.
as
Yes,
time
thank
goes
you.
by and remove
I'm a
some
visual
stuff that
person.
That's a great
basically
thing.
no longer
So,
needed,
since we're going to be
and
ready
that's
to
how the
celebrate,
Hubble
we have our
Space Telescope
champagne flutes.
actually able
The
to do. So
champagne
yeah.
flutes will be our dark matter.
Okay.
They're clear, right? It's invisible.
Sure, invisible.
More or less invisible. And our galaxies will be our iconic Roman Space Telescope logo.
Okay.
Now, the pattern of galaxies is a little like the pattern of letters. It's recognizable. You know what letters should look like. But when dark matter intervenes between us and those letters or those galaxies, as we distort the imagery,
Oh,
you
yeah.
can see the words space telescope are distorted by that dark matter.
I see. I see.
And we can make those maps, and we can then see where the dark matter is distorting the distant galaxies and infer where that dark matter is.
Right.
Just like you could figure out the word space telescope and figure out how much glass is in between the camera and this image.
So again, you might not be able to see the dark matter, the dark energy itself, but because it's distorting things behind it, you're like, something's there.
Yes, because dark matter moves the light around, just like dark energy moves things around in space. We don't see them directly, but we see their impact on the universe. And since dark matter and dark energy are 95% of the total matter and energy that's out there, they dominate everything. All the stars, all the galaxies, they are there because dark matter and dark energy have pushed them and pulled them to be there. And we would like to understand how those work, because that gets at the very fabric of our universe. How did the universe come to be the way it is?
Sure, really clever. A clever tool that we're using here. Now, Roman's wide field instrument will use this technique along with other methods to explore our universe on an enormous, unprecedented scale. But why does seeing that much of the sky at once matter? Leah is back with her next guest. Hey, Leah.
Good morning, Megan. Nice to see you again. I'm here joined by Ami Toy, who's actually our wide field instrument scientist here on the Roman mission. Ami, thank you so much for joining us today. So we just saw Amy and Dominic demonstrating how this wide field instrument actually works, but why do we want to map the sky on this scale? What does it actually tell us?
To understand the universe's biggest questions about dark matter, dark energy, and planets beyond our solar system, we need both the finer details and the really big picture. And imagine photographing a landscape, as Sean just mentioned earlier. Instead of just a single tree here or a mountain peak there, we get the whole picture, and those patterns that are revealed can help us put the whole picture together.
And how is this different from other instruments that we have currently in space? We talked a little bit about the different instruments that are on, but how does that are on Roman? But how does this one actually work differently?
Roman combines Hubble's sharpness, but with 100 times the field of view. And so that means we don't lose the finer
So
details,
in
but we
case
can
in
very
case you want to
efficiently
know,
map out the
very
sky,
sorry.
like
actually
very large
actually
volumes
that
of the sky.
the friend that I
And you
mentioned
can also
I
point
mentioned
at a new
here,
location with Roman and
he actually
settle
called me.
down very quickly.
Literally
And so we
literally
spend more time
literally
taking
just called me,
pictures than
and then
just
and then I
reading.
tried to and then I
So
requested
with the
what
speed, we'll actually
what's
be able to get some more of that
what
data.
the
We'll be
follow
able to
out
get more
what
of it quicker
follow
and be
up
able to
what's happening
understand
and
and
whatnot.
unravel some of those
And I
mysteries a
can
little
say
bit
the
faster.
condition is really good
So
so
currently we
far.
know of about
Maybe
6,000
just need to
exoplanets,
do
but how
some
many
final
more
check,
are you
but
guys
the rest of it should
anticipating
be
that
good.
this wide field
So
instrument
yeah.
will reveal?
We're anticipating around
Nice.
100,000 new previously undiscovered exoplanets, including about 1,000 that will be revealed through microlensing, a specific type of gravitational lensing. And so we will learn a lot about cold, rocky planets and potentially some in the habitable zones of their stars.
Really? Okay. So,
But anyhow,
so you're
we
actually
have
looking.
less than
This is
2
going to be
minutes
used in
before the
conjunction with the
second stage
Habitable
engine
World
start
Observatory
number
that
2.
we
We
heard
will see that
that we
soon
heard
on the
Dr.
vacuum
Fox talk about a
Merlin
little bit earlier.
rocket engine
That's
on
right.
the
It'll
second
help pave
stage
the
of
way
the
for habitable
Falcon
worlds.
Heavy rocket. So we will
Ami,
see that
thank you so
soon.
much for joining us today. And Megan and Dominic, we're going to send it back to you.
Thank you so much, guys. Another look at the crowd there. 23 minutes after launch, and they're still so excited to be here as we continue.
Oh
to
yeah,
celebrate
look
as
at
the
that.
Falcon Heavy's
The
second stage
excitement.
continues its journey out with Rocket.
Wow.
Back to SpaceX for
Look
that next
at
operational
that.
milestone.
How exciting as well.
Thanks, Megan. Now, just to recap everything that's happened so
1
far,
minute
we
before
had an
the
on-time
second stage
liftoff of
engine
Falcon
start
Heavy
number
from
2,
historic launch complex
SES2. We
39A
will
in
see
Florida
that soon.
at 7:26 a.m. Eastern Time. A few minutes after that, we jettisoned the 2 side cores, with the center core jettisoned shortly after. And those 2 side core boosters performed boost back burns and made their way back to Florida for landings at landing
Oh,
zone 2
finally!
and landing zone 40.
That
And you can see
another
those there on your screen. Landing zone
another
40 on the
boosters
left,
there.
landing zone 2 on the
Yeah,
right.
so everything is landing
And the
perfectly.
second stage performed the first
Thank
of
goodness.
2
Thank
burns,
goodness.
which lasted. Next major milestone coming up in just under 30 seconds from now.
That's what we
will
want
be
to
the second
look at.
engine
That.
light.
That's
On
what
that
we want
MVAC,
to. That's what we want to see.
and that
That's a very
burn
good
is
sign.
set to last for about 2 minutes. Second and final burn of the Orion Space Telescope on its way to the Sun-Earth L2 point.
Get ready.
Now, as mentioned earlier, L2 is the Lagrange point on the opposite side of Earth from the Sun.
We will hear the call out
approximately 4 times farther from Earth
for the
than the Moon.
SES2.
So we should be hearing that
Second
call out for
stage
SES2
engine start number 2.
momentarily.
We'll get ready. Okay, so already start. So the second stage engine start number 2 has already initiated. And this will happen up until T plus 26 minutes and 32 seconds. We will hear the call out as well for the second stage engine cutoff
And
number
we are,
2.
of course, able to monitor the vehicle's telemetry via
Oh.
the graphics that we have at the bottom of your screen.
Okay,
there.
the velocity is
The
still
engine
increasing.
that is currently firing is, of course, the Merlin
Velocity is
vacuum or
30,000
MVAC engine
kilometers
located
per
on the second
hour.
stage.
Altitude is
Now, this engine has a
192
much larger
kilometers.
nozzle than the sea-level
And
M1
currently
engines
on the
located
G-force
at
on
the
the
bottoms of
upper
the
stage
3
and
boosters
the
that
Nancy
made up
Grace
the first
Roman
stage.
Space
Now, we
Telescope
unfortunately
fell right
don't
now
have
is
views
2.6
of
G,
that
G
engine burning right
and
now.
still
Now, the
rising
extended
up,
nozzle allows
but
for
still
optimal
okay.
performance of the in the vacuum of space, where there's no
Yeah,
atmosphere to burn in.
and also
Each
another
M1T
reason
engine
why
can produce
you
a
need
max
the
thrust of about
bigger
198,000
bigger
pounds of force
nozzle
at sea
on
level,
the
whereas this
in the
MVAC
space
engine can
environment, in the
output
vacuum
about
environment, is that
220,500 pounds
the
of thrust in vacuum.
let's just say in the nutshell, basically the rocket flames it will go
Now, we've still got
expanding and
about 30 seconds
infinitely
left
expanding
of
up
this
until
MVAC engine
the
Taking a look
certain
ahead in
point,
the mission
especially
of this burn, we will then have payload
especially
deployment
the
of the Roman Space
tail end of
Telescope,
the
and that
rocket
deployment is
flame
set
there,
for the
and
T
that's
plus
going to
31
cause
minute and
lots of
31 second mark.
quite
And we should be hearing that call
significant
out for SECO 2
thrust
in just
efficiency
about
and
10 seconds from now.
effectiveness loss. And to combat this stuff, all you need to do is just widen up, largen up, and do whatever is it necessary for the nozzle there. And we shall see soon. Okay, second stage engine shutdown number 2.
And just standing by for
Sorry,
the call out
second
of
stage
SECO 2.
engine cutoff number 2. Correction.
On your screen right now, you can see
orbit insertion.
Okay,
And there we heard
nominal
that call out
orbit
for nominal
insertion.
orbital
Pretty
insertion.
good. And get ready for
and with
the
that, we've still got one more
Nancy
major
Grace
event
Roman
coming up,
Space Telescope to be
which is the
deployed.
most
And that's
important
very
one, and
good
that is, of
things that
course,
we want to
payload
hear.
deployment of the Nancy Grace Roman Space Telescope in just under 5
And
minutes.
after
How are things
and then
looking
after
over at
that,
Kennedy, Megan?
all of the journey for the
Exactly.
Nancy
Looking
Grace
really good
Roman
over
Space
here.
Telescope will
It's
begin,
exciting
or
to see that
in this
we're
case,
nearly
we're
there
gonna
and
call
get
it
to see
Roman
live
Space
images of
Telescope.
Roman
We will
Space
see that soon.
Telescope.
Will
Now, we
happen
just told you about
live
Roman's wide field
right now
instrument, making
from
its prime
NASA
time
and
science
SpaceX.
second instrument, and that is its
And that's a very
coronagraph,
good
a
things
technology
that we want to
demonstration designed
hear
and
so
built
far.
by NASA Jet Propulsion Laboratory to
Oh,
test how we
here
can
you can look at that.
block the bright glare of a star to see the
Yeah,
much
that
fainter
one is
planets
the
orbiting our planet. So
yeah,
Simon,
the
this will eventually help
not
future
the
telescopes, we were talking
chronograph.
about this
Yeah, yeah,
before, maybe
chronograph. I
find
I
other
actually
planets
meant to
like
say
our solar system
chronograph,
like
but
ours.
instead
Megan, this is an
spectrograph. But also
extraordinarily
technically
challenging
not
problem. You
entirely
saw on that
wrong
on
as
that
well
little
because
video there,
the
the
spectrograph,
planet being
if I
lost
remember,
to the
also
glare
something
of
to
the
do
magnum star. A planet
regarding the
like
research
Jupiter
of the
is 10
of
million
the
times fainter than the
exoplanets,
star that it's around. A planet like Earth
exoplanets,
is 1 in
atmospheric
10
chemical
billionth
composition
size
as
of
well.
the
Yeah,
star.
yeah,
So
that
you
one.
have to block that
Technically, it's
starlight
kinda
exclusively.
correct,
The
but
Roman coronagraph
but yeah,
demonstrates all the
I
technologies
mismentioned
necessary
it. It's
for time
okay.
and space.
Wow.
And a future
But it's okay.
telescope,
We are still
the
learning,
Habitable Worlds
and
Observatory,
it's
will
fine.
then carry that
You know,
forward to measure the light
because at the
from
end
an
of the day,
Earth-like planet around a Sun-like star, look at its
I'm,
atmosphere, and tell us
I'm not
whether
learning.
there are
How do I
potentially
say?
signs of life on
I'm
other
not
worlds.
the
Again, just always
person.
advancing what we do here at NASA. I love
Let's
that.
just say,
Pushing the
how do I
boundaries of
say?
capability and knowledge
I
I
love that.
every day.
All right,
I'm
we are
not
now just a
I'm not
few minutes
100%
away from
expert
Roman
enough
separating from the
about the
Falcon Heavy
aerospace and
second
also
stage.
about
Our
the space
broadcast
science,
starts shortly
especially
after
the
that, but you can keep
astronomy
learning
stuff.
more
So
about this
yeah,
mission
please,
here.
be patient with me as well. I'm just a
Get ready for NASA's
university
new view of the
student
universe
learning
and the Nancy Grace Roman Space Telescope
computer
with a special
science at
limited
the end of the
series
day.
of
So yeah,
NASA's Curious Universe.
So you're
degree
asking for the 10-second
specifically if you
description
want
of
to
how
know.
the universe entirely
So
works.
please be patient with me.
We're building one-of-a-kind satellites. It's never been built before. No one's going to build this again.
Want to go deeper? Find
Yeah.
the story behind Roman at nasa.gov/podcasts.
Yeah, the gravitational
or wherever
lensing
you
as
get your
well.
podcasts.
Ah.
The idea of pulling back the curtain on so much of the universe
Okay,
that we still
less
don't
than
know
2
yet is
minutes
super
before the
intriguing, not just for
Roman
scientists,
Space
but also
Telescope to
artists too,
be
like singer
separated
songwriters.
from the upstage. We will see that soon happening.
It's Jewel, and as you may know, I make artwork using astrophysical data, and there would be no data more fascinating than dark energy and
Ah.
dark matter. And so it is with this great wish of great success and Godspeed that I wish the Nancy Grace Roman Space Telescope. So exciting.
We're expecting Roman to soon separate from the
Aha.
Falcon Heavy's second
Get
stage,
ready.
so let's watch that moment unfold with Steve and Jared.
Okay,
Thanks, Megan. We
here we
are
go.
about a minute and a half away from that expected separation of the Roman Space Telescope from the Falcon Heavy's second stage that has gotten it into.
I mean, this is also one of the most anticipated mission out of all after like decades at this point.
So far, so good.
So yeah,
Everything's
it's
been right down the middle.
you have every
As
right
far as
to actually
stage,
feel very
stage two,
excited,
burn
just
one
like
and burn two.
the
Perfect.
James Webb
And
Space
so
Telescope's
really good
launch
so far.
back
It's been a
in
great morning.
And
on
also
Christmas
we did have
2021. So yeah,
confirmation. We did get,
you have every
confirmation from
right
the
to be very
spacecraft itself,
excited about this mission.
So
let's
early
go
in the
and
launch,
keep
around
watching.
7 minutes, so,
Get
first
ready for the
acquisition of signal or pulse
Roman
from the
Space Telescope to
spacecraft.
be deployed and
That
to be
was a big
separated
milestone
out,
as well.
whereas the mission will finally
we,
begin for the
as
Roman
we
Space
look for
Telescope
another
and the
30 seconds,
astronomical
I'm sorry,
data, all whatnot.
another 30
Moving
seconds
forward, we
before,
will see that soon.
before that separation comes.
Get ready.
Roman is, of course, recharging its batteries
20
on
seconds
solar
from now.
power, and looking forward to that flying free on its own.
Yeah, hopefully we'll get a good shot of stage 2
10
here.
seconds from now.
They usually have a great forward-looking camera from the top
Okay,
of
the
the
velocity is
stage 2 to see,
36,600 kilometers per hour.
we have a
Altitude is
shot
still
of
rising
the,
up, 715 kilometers and
Mission
up.
Director Center here at
Get ready
Kennedy
for the
Space
deploy.
Let's see if we can see.
Nancy Grace Roman Space Telescope separation.
Beautiful.
And
there we go.
Beautiful, beautiful.
Roman
That's
Space
the
Telescope flying
that's the
free
thing that
on
we
its
want
way
to
to the
see.
Orion
Beautiful. And now the
open
Nancy
new
Grace
line in the
Roman Space
universe.
Telescope has already
Of course, a
begun
lot of celebration
to open
with
up
team,
the
Jared.
minds
I know,
of us humanity
you
about
represent a
the
lot of people in NASA's
about exploring
World
what's
Services program
possible about
across
this
NASA.
universe
A
and
lot
also
that goes
to
into
explore
this.
more about the
I hope you
exoplanet,
have enjoyed it. We've enjoyed having
dark
you.
matter,
Yeah,
dark
it's been
energy,
great. Yeah,
and a
wonderful.
tons
Spacecraft
slew more
deploy. Here are all the
about
clouds
the
here,
mission.
numbers and
So
mission address and the mission
congratulations
control
initially.
room.
So this is a very good
Thanks so much
sign
for
so far.
today. And,
This is it. The
most
Roman Space
importantly,
Telescope has
congratulations
already
to the whole Roman team
separated
on
from
behalf
the
of Launch Services program.
from the
It's
payload
been great
adapter
working with
stuff.
everybody, and
So
we
that's
really look forward to
really
seeing
good. That's what we want to see
It's going to be
so far.
terrific.
Yes.
Roman is on its way, and
This
we're
is
going
very
back to
good.
Zach
And
for
yeah,
our Falcon
it's
Heavy
also
spacecraft.
very understated as well, not to be very excited about
Stephen,
this.
Jared, and what a
And yeah, you can see
spectacular deployment.
there's also
Of course, a
there's
huge
also
thank you
antenna
from
there
SpaceX
to
everyone at NASA
connect
for the
between
partnership
the
on this mission, and
NASA's
to all the teams on both sides
ground
who
tracking
brought
station,
NASA's
especially
Nancy Grace Roman
the
Space Telescope
Deep
to the
Space
pad and into
Network
space.
and
Now,
whatnot,
with the launch completed and
with the
successful deployment
Nancy
from our
Grace
second
Roman
stage,
Space
that's going to go
Telescope.
to
So
space
that's a
here
very
in
good
Concord.
sign. We
So I'll
want
hand
to
it
see
back
that.
to the NASA team from here.
Yeah.
Over to you, Megan.
That's a very
Thank you
good
to our
one.
launch commentators, and yes, to SpaceX as well as NASA's Launch Services Program for getting Roman onto a trajectory towards Lagrange Point 2 or L2. And now the spacecraft team
Yeah.
will take over, so let's hear from Leah with her last guess.
Hi, Megan. I'm actually
Okay,
joined here by
and
Jeremy
also we
Perkins,
are
who's part of
going
our
to see
science
this
mission
last
team.
part
And
before
I have
we
to tell
end
you
this
something
stream,
that
and
funny that just
also
happened. He
myself
walked in
have
right
to
after
take
launch and he was
have
showing
to
me
have some
on
dinner
his watch
before
this
I'm
really
going
interesting pattern
again
of a
for
regular
to
heart
my
rate, and right
friends
at 7:26,
attending
this
for
huge
the
spike. So
for his
super
laptop.
exciting day
Need
for
to do
you.
one
Super
more
exciting
last
day
time
for your
check, and then
team. We
yeah,
launched just
that's
about half
basically
an
it.
hour ago. Hope
We're
your
going
heart
to
rate's
see that.
starting to settle down just a little bit. So things
And
are
yeah,
starting
and
to simmer up,
also
but it's
and
actually
and
just now
also
picking up
I'm
for
going to
the
put
mission team.
the
What are you guys
timestamp
doing
as
now?
well
What's next on the
in
board?
the
Yeah, so coming up
in the
next few
pinned comment
hours,
section. So don't
I
worry,
mean, I think I just saw the
you can
video of us
actually just
deploying
click
from the
where's the
rocket, but
point
we
for the launch
contact
and
and
also the
then we
deployment. So
get our solar panels pointed
yeah,
at the sun
that's
so we
also
can make sure
pretty
we get
good and
power going to the system
awesome
because
as
we're on internal
well.
power right now. Yeah. And then over the next day or so, we're going to do a mid-course correction where we make sure we're in the right
Yeah, mid-course
way to get
correction.
to L2, about 1 million miles from Earth. And then over the next days, we're going to be deploying our high-gain antenna, which is about as, I mean, if you were watching the video just now, you saw it as we were going away from the space vehicle. It's about as round as I am tall.
Oh, wow.
And that's just to get down the amount of data that Ami and other folks talked about earlier, back down to the ground.
And how much data are we talking about?
So we're talking about a terabyte of data a day from L2. So the way that I like to think about that is it's like 1 million songs that we're streaming from 1 million miles away every single day for the lifetime of Roman.
Oh my goodness.
Yeah.
Yeah,
The
so
team
that's
of
basically
engineers,
it.
who are responsible for designing and building the spacecraft are actually watching this unfold right now. What are they looking for?
So like you said, the folks that designed, built, and integrated Roman are actually sitting on console right now.
Okay,
just
so
paying
this is the
attention to
animation how
every
it looks like when it
detail about
deploys.
Roman. I mean, there's thermal
That one, if I
engineers who are
remember
looking at all the
also
temperatures.
also
There's
correctly,
folks
that
making
one
sure
is
the
also
deployments
the
are going okay. There's folks that are making sure the
radiator as well
communications are
to
working.
keep the
And so there's just a whole
to keep
crew
the
of folks
Roman Space
here
Telescope
on
cools down
campus at
as well,
Kennedy and up in
despite
Greenbelt
all
and
of
all
that
over the
heat
country
out.
that are actually
And you
monitoring
can see
Roman
that's
as it
how
goes to
it's
L2.
And this is
it
only
actually
their first
going
look
to
because some of
deploy
this
the solar
instrumentation
panel and
actually
also
hasn't
the
even been used or
heat
tested
radiator
since
as
it
well,
was
and also
first
eventually
tested
the
before it
antenna
even
as well
integrated
pointing
or
to the
put
Earth,
into fairings or put on a rocket.
Correct.
especially
The
to
last
the
time we'd really turned
NASA's
instruments all the way on
tracking
was back
station
when we did
around the
all that
world.
months ago.
Oh my goodness.
Yeah.
And so we're going to be going through a period
And
of what's
also
called
especially to the
scientific commissioning, which is
TDRS, the
kind of that
TDWIS,
official
tracking
handover from the
data
engineering
and
team who's doing the checkouts to the science team.
relay
Yep.
Tell us a
satellite
little bit
system.
about
And
timeline
you
on
can
this
see
one.
after that it
Yeah,
will
so
open
we're
the
going to be checking out Roman
opener there,
for about a month, and then we're going to be aligning
how do I
and
say, the
focusing the telescope, making sure we get all
protective
the pointing
opener
right,
there,
and then we get into science
that's
commissioning, like you said. That's
surrounding,
where we're really just
that's
checking
actually
out the
in front
instruments,
surrounding
pointing at the sky,
the
getting
first
our
half
first
of the
starlight on the detectors for the first time, and doing that handover
optical,
from
how do I say,
engineering to
the optical
science,
mirror
which
there.
is when the
So
science
yeah,
team really starts to get involved in really
and also the
understanding how the
magnifier
Roman
as well.
instrument works.
And then we get
That
those
bounces,
images, and we're going to be
that
sharing those
taking,
with the world. So Jeremy, thank you
that's
so much for
basically
being
taking
here.
light from
Congratulations to your
the
team. And
optical
Megan
mirror
and
to
Dominic, we're
the
going to send it back to you for the last time.
in front of it. So yeah.
I'm sure that
And that was another
that Jeremy was wearing.
another hype as well from the Kennedy Space Center.
36
This
minutes
is
ago when there
that's
was
a very
launch
good
of,
sign
Roman
we want to
right from here
hear.
at Kennedy Space Center. So Dominic, I want to take time to take more questions. We had so many of you send in great questions throughout the broadcast, so we have time for a few more. Let's take the first one.
Absolutely.
Okay,
What do we have?
so another one as well.
How would repairs or refueling Roman work given the distance of the telescope from Earth?
Very good question.
Great question.
Serious.
We did design Roman to be at least refuelable so that its fuel ports are accessible. A sufficiently advanced robotic refueling spacecraft could get out there to 1 million miles away could rendezvous and dock with Roman, grapple with it, and add more fuel. That could extend its lifetime to give it even more time to map the cosmos.
But is that the plan, to refuel it? Hopefully not.
We don't have a plan to do that, but we designed it in so that it could be possible. We didn't want to preclude the possibility of extending the lifetime, but it relies on servicing capabilities that are still in
especially just in case, let's just say,
it is perfect.
maybe just in case
But we want
there's
more
possibly future mission,
All right, let's
especially
take
with the
another question now.
Starship,
Let's see.
to actually go and rendezvous and
What-
edit
oh my
kinds
God,
of
what
stuff
light
as well.
spectra does Roman operate with? So sorry,
Oh,
guys,
light
terrible vision I
spectra.
have.
That's fine.
Roman
So the Hubble
operate
Space
with
Telescope
very
was
good question
designed
as well.
primarily for ultraviolet and visible light. It extends a little bit into the
Yeah,
infrared.
the
James
UV
Webb Space Telescope is designed
UV
to focus
visible
on
light
the
and
infrared
also
and out into longer
part of
wavelengths.
the
Roman
IR,
bridges that gap.
infrared.
It is sensitive to light in the near in the visible range, and say orange light, but goes further out into the infrared than Hubble can. And with that infrared vision, it penetrates through clouds of gas and dust and sees farther into our galaxy or into star-forming regions than has been possible with visible light.
Wow. Okay. Well, and again, remember we did ask some folks to vote on Twitter
Yeah,
about
so
what
that's
they'd be
basically
most to study. Roman would be most excited to study. So let's pull up you guys' answers now. Again, it was dark energy, dark matter, planetary systems. Oh, that is not surprising there. Dark
Yeah, I'm not
energy and
surprised.
dark
I
matter
actually
dominate.
like dark
That is
energy
what we
and
built
dark
the
matter.
mission to
I want
do,
to.
among other things, and it's part of the
I like
key
this kind of
questions about the
research the most
universe
actually.
time that Roman will unlock for us.
Yeah. Again, there's just so much we don't know about it. So of course there must be so much curiosity around it.
There is so much out there to discover. We do not understand a lot about the universe, and Roman was designed to give us the data we need to answer countless questions.
Got it. And then
Yeah,
another quick
so
note,
that's
don't
basically
forget about Roman's Adopt a Pixel campaign. We debuted it earlier. A single Roman image will have 300 million
Oh.
pixels, and we are inviting you to sign up for one of those pixels by visiting nasa.gov/adopt
Oh, okay,
Again,
okay,
how
okay.
cool is
That's
that?
very
Little
interesting.
cosmic
You can
dot in
sign
the
this
universe.
up
I
if
hope
you
you're gonna
want.
sign up.
Maybe I
Oh,
want as well.
absolutely. I don't know what my pixel will
I would
contain.
like.
Will it be a star? Will it be a galaxy?
I
Will
would
that
like to
star explode?
try.
Who knows?
Yeah, will the star
Which one
explode?
will
Yeah,
you
that would
adopt?
be great. I would love anything. I mean, I just think it's so great to call, to be able to call some part of this beautiful images that we're going to see my own. So that's a really fun campaign.
Yes.
Thank you to those who developed it. All right, so that's going to do it for us here.
Yeah,
Kennedy
so
Space
therefore
Center,
it
live
ended it.
coverage of NASA's
Yeah,
next-generation
nice,
Roman
nice,
Space
nice.
Telescope mission.
And I'm
A
going to
huge
have my
everyone
dinner, so
involved, and a big thank you to everyone
just
who
in time.
participated in our broadcast. Of course, especially to you, Dominic. It was so great having you.
It was thrilling to be here with you, Megan. I couldn't have had a better partner to go through this launch with. It has been an amazing day. Roman had a beautiful, picture-perfect launch. It's going out on its way to space, where it's going to do fabulous, fantastic
Yeah,
things.
inside
And we just want
the
to give a shout
mission
out again
control
to the
as well.
teams over at
So that's
Goddard.
very
We had our
good.
launch support room over there, specifically supporting launch operations, and then we also had the mission operations room. Oh, they're waving now. Congratulations to you all.
Yes, we can see the launch support room on the
Yeah,
right,
I
the
can
mission
say
operations room
decades
on
of
the left.
effort
Those people
finally
are
pays
hard
off.
at work preparing the observatory. In
I
fact,
mean,
it's already
specifically,
operating.
we've been
And
around
over the next
15
several
to
months,
16
we will
years
have
of
a
effort.
hotbed of activity,
It
especially
pays
in the
off.
mission operations room that
That's
you see
very
there. I'll be
good.
sitting in there some of the time as we get the first data back and tune up this observatory to do spectacular, world-changing things.
And I just got word that the spacecraft is power positive. Can you tell us about
Oh,
that?
power
Yes,
positive. So
the
it
solar
powers
arrays are
up,
actively
powers
providing
on.
electricity. It's
Very
no longer running
good.
off of its internal batteries. In fact, hopefully it'll be recharging them at this point. That's necessary because we need all of that electrical power to keep the observatory running smoothly.
Oh my gosh, that's so exciting. Oh, again, I'm getting
Yes,
goosebumps. It's
yes.
so cool to see what we can accomplish together and what NASA continues to do to advance what we do in air and space. So we invite you now to our post-launch news conference. That will take place at 9:30 a.m. Eastern Time on NASA's YouTube and X accounts. We will have NASA leadership and Roman scientists on to answer any of your questions.
Oh,
And remember, launch might
so
be
there's
over, but the
even news
mission has
conference,
just
huh?
begun, as we've been just telling you about.
All
The
right,
team of
all
people,
right.
at Goddard continuing to follow
Hmm.
along with the mission, and you can continue to follow along with us on this groundbreaking journey by going to
Ah, interesting.
NASA.gov/Roman. You're definitely
Maybe
gonna
we
wanna
can
check out our
go.
live
Maybe
broadcast when we will
maybe
reveal
I can
Roman's
go with
first
the
images.
impromptu
We're
as well.
aiming for
So don't
early
worry, we'll do
2027,
that.
Dominic.
Those first images will be iconic in the same way first images from Hubble and Webb have permeated the nation's
Yeah.
consciousness.
So hopefully we are going to be able to look how it looks like for the first slide. So I would like to know as well. So joining the journey with me and with the space community as well. So that's very good.
T minus 15.
Okay, so this is the replay.
7, 6, 5, 4, 3, 2, 1.
Okay, that's what happened on around 42 minutes and 40 seconds ago. Here you can see how the launch actually looks like. Very interesting. Okay, and that's basically it. We've already reached the end. And NASA logo. Yeah, so that's basically it. We've already done. Oh, that's it. So yeah, I'm pretty sorry if it looks a little bit short of stream. Yeah, because like I said earlier on, we have a little bit of I have a little bit of problem I need to tackle with my friend's laptop, but anyhow, here's what it is. You know, typical Microsoft stuff. They constantly will find a way to break your PC even though you don't want to, but well, here's what it is. Unfortunately, my laptop's not yet broken up by update for anything's for real. So yeah. So thank you so much everybody for watching. I really do appreciate and enjoy our time here. Even though I look a little bit of rushing, but yeah. But that one is actually really real. It's not a joke. I'm not making this story up. And especially as you see while the stuff happening behind the scene, I also just talk somewhere else, you know. Especially when I lost the mic, I actually just talk to my friend. So I'm not joking. I'm not kidding. Okay, so that's basically it. And yeah, the most important thing as well, we will also going to see the launch of the apparently GSAT 1A. Yeah, that one is basically the relaunch of the previously failed EOS 3 with the EOS 5, but yeah, some more major instrumentation stuff upgrade here and there. So that's basically why. So yeah, basically that's it. Thank you so much everybody for watching, and I can close this up as it's almost at 12 p.m. here in Sarawak in Borneo. So on 30 right now on 30 August 2026 on Sunday. So I'm going to close this up. Thank you so much everybody for watching. I'm Dennis Suguwa, your host today for the launch of the SpaceX's Falcon 9 heavy rocket carrying the NASA's Nancy Grace Roman Space Telescope. Already launched today, and it so far so good. Initially success, so that's a very good thing we want to see. So thank you so much everybody for watching, and I'm going to have my dinner pretty much because I'm hungry right now. So thank you so much, and also because there's not much chat out other than Dev's initial chat just saying hey again. I replied and no reply, but it's okay, it's fine. You don't have any obligation to reply. Just keep it like that, also fine. So thank you so much everybody for watching. Take care and stay safe. We will see that soon. I'm not 100% sure whether or not I can check out. And yeah, hello Kimi. Yeah, I'm very sorry that you've already arrived at around this last moment, or maybe you have already lurked this before, but yeah, I don't know. I'm how do I want to say, I want to have a dinner, but before that I don't know. I'm very sorry in advance, but I hope you don't mind if you want to subscribe to my channel. You want to press the hype button up how many times you want, and also click like, subscribe, maybe even share, or maybe even comment as well. That's also appreciated. But you know what you're gonna do. I'm not going to tell you that much. If you want, you can, but if you don't want, that's up to you. That's fine. I'm also going to put in in the comment section of the timestamp as well, where the launch actually happens and eventually where the deployments happen as well. So I'm going to do that before I'm going for dinner. Yeah. So that's going to take around 1-2 minutes. After that, yeah, basically we are done. So thank you so much everybody for watching, and take care, stay safe, and yeah, hello Kimi. I'm very glad you're actually coming here, even though it's last minute, or maybe you've already lurked here like a few minutes, maybe a few and 10 of minutes ago, but you just decided to just chime in and says hello. It's okay, it's fine. We will see you soon. Yeah, and if I can get everything else done, I will also going to stream the post launch of the Nancy Grace Roman Space Telescope of the NASA conference, live conference as well. Hopefully I can go right on time. So thank you so much everybody for watching. Take care and stay safe. I'm going to have my dinner. It's almost 8:15 p.m. so on 30 August 2026 on Sunday. So in Borneo. So good time. I need to go. Thank you so much everybody for watching, and take care, stay safe, and bye-bye. See you soon. And yeah, take care. And nothing else I want to say. Just enjoy this. And yeah, I say LC39B. Wow. I was wrong. It's actually LC39A. Launch Complex 39A, not 39B. Okay, because 39B is where the space launch system, the SLS rocket, actually launched. So yeah, my bad. But well, that's what actually happened when you're a bit rushing after you help your friends, your friend with the laptops. But well, it's okay. It's fine. It's fine. Daijobu. Things happen. Mana-mana aja. Smooth time mana aja. Everything is all right. So yeah, that's Iniban, in case you're wondering. So thank you so much, and bye-bye. Stay safe. Bye-bye. Take care.